Let's understand a supernova. Near the end of its life, a massive star runs out of usable fuel. Without that fuel, the outward pressure holding the star up disappears. Gravity immediately takes over, and the core begins to collapse rapidly under its own weight, and as it does, material from the surrounding layers starts falling inward toward the core. As the collapse continues, electrons are forced into protons, forming neutrons, and releasing neutrinos that carry away enormous amounts of energy. Some of the neutrinos escape outward, while many are briefly trapped inside the collapsing core. The core heats up to billions of degrees and becomes increasingly neutron-rich. Eventually, the core becomes so dense that neutrons are packed as tightly as possible and resist being squeezed any further. This abruptly halts the collapse. The core rebounds slightly, sending a small shock wave outward. That shock briefly slows the infalling stellar material and creates a thin layer just above the core. At the same time, huge numbers of neutrinos stream outward from the core. A small fraction of them deposit energy into this layer, heating it even more. The heated material becomes buoyant. Turbulence increases pressure, and the shock is revived. This creates a feedback loop until the shock overcomes gravity and blasts the stellar mass into space as a supernova.